All right, everybody. We're going to do retrosynthetic analysis from test 2 of fall 2021. Question 5 in the fourth part. Big one, 26 points. First job you have to do is identify which of these two syntheses is the appropriate one. I'll do a quick review here. Won't take 2 seconds. Well, it will. Malonic ester synthesis generates derivatives of acetic acid. And acetoacetic ester synthesis generates derivatives of acetone. Derivatives stands for derivatives. So if you see acetone included in your target, then you want the acetoacetic ester. I do not. I see acetic acid right there. If there's an H there instead of the CH3, that's a derivative of acetic acid. That means you're doing the malonic ester synthesis. Good. So somewhere you're going to have, hey, I just had inspiration here. I'm going to do this one very differently than I've ever done it. You're not allowed to start with that molecule, but that's diethyl malonate. It's a malonic ester. You know you have to use it. That's what I'm saying. In the forward direction, you got to put groups on it. And why do we love the malonic ester synthesis or the acetoacetic? Because this H is easily removed with cheap, strong base. You're taking that H off and generating a minus. Then you put one of those two groups on. It better have a leaving group on it because you just generated an anion. So I'll put the homobenzylic group on first. What? It's benzylic with an extra CH2. That's called homobenzylic. And sometimes retro is overrated. Or if you're stuck, do the forward synthesis and then pretend you knew how to do the retro all along. Oh, that's sneaky, Dr. Whitaker. CH2 once, twice, but. There you go. We're well on our way to making this target, right? You do the whole thing again with the other alpha H that you didn't use the first time. This one, still pKa 10. Glorious. Step 1, NaOH. Takes the H off. Step 2, this time I need an isopentyl group with a halogen. Want to stick with Br for the whole thing? Why not? Br 1, 2, 3, 4 with a V on it. And there, you've got this lovely guy right here. And coming down, going up. Doesn't quite look like the target, but we're getting closer. One, two, three, 4 with a V. So we got the groups on. You might think, oh, why didn't he start with a methyl ester? Because his product's got a methyl ester. Guys, in both of these syntheses, you have to do saponification, acidification, decarboxylation to get rid of one of the carboxylic groups. So I don't care what ester you had here, you're going to remake this ester later. In fact, it is time. How do you know it's time for saponification, acidification, decarboxylation? Because you got your 2 new R groups on your malonic ester. So after you've put your 2 new R groups on your malonic ester, it's time for the rap song. You can't write the rap song for points. I'm sorry. You got to know sodium hydroxide in water is what's used for saponification. And acidification is usually HCl. And you don't get decarboxylation until you heat it. And you are so close to your target molecule, you can taste it. I would not taste this tablet molecule. It's probably toxic. All right. CH2, CH2C, CH2, CH2F. You are now down to CO2H up here. We need to do an esterification. Now, I don't know how I feel about this. If you use diazomethane, you're typically not obeying your guidelines. Unless you know how to make diazomethane, which I never taught you, and it's actually not very easy. I would use the old Fisher esterification just to be safe. CH3OH, H2SO4, and heat. Before you think we're done, we're not even close, ladies and gentlemen. I mean, we are getting closer. But there's a lot of carbons here that aren't on our list of allowed molecules. This is not on your list. This one's not on your list. This one's one away from something on the list. Let's go green for making reactants. PBr3. And that's something that is on the list. Alcohols of, oh, that was a typo. I believe that's corrected on the answer key. I just saw it right now. I apologize. I'm not going to make you make isopentanol from a smaller alcohol. No. We already have something that needs to be extended over here, and you guys know how to do extensions. This is not benzyl bromide. It's homobenzyl bromide. It's made from homobenzyl alcohol. Which is not benzyl alcohol. You have to make that from benzyl lithium and formaldehyde. And those two will combine after you mix them and then react them with HCl. I hope this rings a bell because we did that on our last retro. And you're still not done because this is not an alcohol of 5 carbons or less, but it's real close. It came from oxidizing an alcohol of 1 carbon. This came from an alkyl bromide. You cannot make an organolithium from an alcohol. Please don't pretend to be the first one that can do that. You can only make them from alkyl bromide, which are not on the list. Not on the list, it means you have to make it. Oh, I didn't show how to make the formaldehyde. All wrapped up in this one. We'll finish this one first. That's PBr3 again. PBr3. This one is PCC. And the P's are very different, right? That's pyridinium, no phosphorus there, and that is phosphorus. And you are not allowed to start with a malonic ester either. Wow. Esters come from carboxylic acids and alcohols. There's malonic acid. Just a little reminder, I said it, but I never wrote it. Malonic ester. This is malonic acid. And that would be ethanol and sulfuric acid and heat. And where's malonic acid come from? Well, it said you're allowed to use diols of 3 well, it was a typo, 5 carbons or less. The typo was based on the fact you do need to use this diol. It was like a hint typo. I don't know, it wasn't. It was a mistake. I can't sugarcoat it. It was just a mistake. You're gonna need the chromic acid reaction. Okay. So here we go. Now it's time to pretend we did this as a retro in the first place. This came from this molecule. That one's covered. Where'd this come from? This one came from this molecule. We need a retro arrow. Need a righteous retro arrow, hot pink. And this was a starting material. Circle those in yellow. You don't have to circle your starting materials. I just like to do it to make sure. Everything circled should be either an alcohol of 5 carbons or less, or benzyl alcohol. Benzyl alcohol over here. Very nice. And back to pink. Where'd this come from? Well, it came from, wow, okay, a little tricky. It came from, oh, I don't know. Well, I do know. And it came from, oh boy. I don't know, you're not gonna like it. Came from both those, didn't it? Doesn't look artsy. For me, that's something. Okay. This came from this piece reacting with this piece. And that piece came from here. And once again, this piece came from, this guy came from this one. And from this one. Those two things had to come together. And our forward synthesis shows it. This combines with that and that to make that. And this came from, go with a lighter retro arrow, just so that I'm confused. That came from there. And that came from these two pieces. That one and that one. And we lost our 2 here. And this piece here, I think this piece came from this piece. And that piece came from this piece. And this piece came from this piece. And this piece came from these 2 pieces. That's where the ethyls came from. And that came from that. I think you can still tell I didn't do the pink part first, but I won't tell. And there you have it in a nutshell. So when stuck on a retro, try to do the forward synthesis. Once you've identified that it's a malonic ester synthesis, at least draw the malonic ester and then put the groups on it. Then worry about making the groups that go on it. I hope that was helpful. And I'm going to come back and see if we have more questions. I'll give you a few minutes. I'll be back right away, and then I'll wait for a while.